Alright guys, so in section 12.4 we're going to start talking about three-dimensional figures. Up to this point we've only talked about two-dimensional, mostly circles, but in this lesson we'll finally start getting into those three-dimensionals. So to start off, we're going to talk about naming them. So if we look at our key concept here, you'll notice that everything is being named by either a prism or a pyramid. So that is based off of the number of bases. So if you'll see in our triangular prism, we have two triangle bases. Your bases are your parallel shapes. In our rectangular base, or prism, we have two rectangular bases. Then when we move to a pyramid, you'll see in our triangular pyramid, we still have a triangle base, but there's only one of them. So same with our rectangular pyramid, called rectangular because it has a rectangle base, but again, there's only one. That's what makes it a pyramid. Alright, so this slide here, guys, is basically just referring back to everything that I was just saying on the last slide. So a prism is a polyhedron with two parallel congruent faces called bases. So again, if we look at this prism here, we see there are 5 sides to these bases, making it a pentagon. So that would be a pentagonal prism. Then a pyramid is a polyhedron with one base, that is a polygon, and 3 or more triangular faces that meet at a common vertex. So if we check out this pyramid here, we have that one common vertex at the top. We have a base that has 6 sides, which makes it a hexagon. So that would be a hexagonal pyramid. So one base, that's a hexagon. And then, meaning prisms and pyramids are named by the shape of their bases, which is what I was talking about here with the hexagon and the pentagons. There are solids that are not polyhedrons. A cylinder is a three-dimensional figure with two parallel congruent circular bases connected by a curved surface. So if we take a look at our cylinder here, we have these two circular bases. That makes it a cylinder. And a cone is a three-dimensional figure with one circular base connected by a curved surface to a single vertex. So here we have our cone. We all know what a cone is. I think ice cream cone. Traffic cone, we've seen them before. Alright, so now we're going to talk about naming. So, in this shape here, I see I have triangular bases. There are 2 of them. They are the parallel congruent sides, that makes them bases. Now notice in this shape here, the base is not on the top and the bottom. The base is side to side. The base does not mean top and bottom. Again, it means those 2 parallel sides. It's the shape of the figure, so to speak. So since there are 2 bases and they are triangles, we would call this a triangular prism. So prism saying that we have 2 of them, triangular saying that the base is a triangle again. So now we want to name a vertex. So our vertex is each of these points here. It's where 2 of the edges meet. So our vertex is going to be any of these letters. Make sure you guys use capital letters. Now it says to just name one, but I'm going to go ahead and name all of them. So for our vertex, we have A, we have point B, we have point C, D, E, and F. I think I got all of them there. All right, your edges then would be the sides. Now be careful when you're naming your edges. You must use a line above your letters in order to represent that it is a line segment. So for instance, we would say segment AB. So one of our sides is AB, and then we put a line over top of AB to represent that it is a line segment. So we have segment AB, we have segment BC, we have segment CD, we have segment DF, segment DE, we have line segment AF, and then going across the top there we also have segment BE. I think I got all of them there. Now notice if I take a look at AB, understand that AB and segment BA, they would represent the same thing, so you would not have to write them twice. if I count through here, I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I think we got all of them. Oop. Looks like I missed EF here, so it's line segment EF. Okay, so your edges are just your sides. Again, you're naming two of the vertices that create a side when connected, and make sure we put our line over top, representing that it is a line segment. Okay, so our faces then, they are our sides. So, if you take a look, so like if I go from A to B to E to F, that would be one of our sides there. So our face would be A, B, E, F. Now, we could start at any one of those points, but notice you have to go in order. We couldn't go A, B, F, E. It has to go A, B, E, F because we follow it around to make the shape, to make the face. So that's one of our faces. Another face could be B, C, D, E. It's our back square there. If I go ahead and take care of that last square, the bottom, so from A to C to D to F, so we have A, C, D, F. That's kind of hard to see some of them since I colored it in pink, but now that takes care of our 3 rectangular faces. Now we can include our bases as well, so we have A, B, C, that's that back triangle. And then in the front here, I'll start at E, so E, D, F. So again, your faces are just your shapes. They're your sides. So we've gone from just one point on our vertex, then connect the vertices to create an edge, and then connect our edges to make our faces. Now, the last thing we want to name here is our pair of skew lines. So skew lines mean that they are not on the same face, and they would never intersect. So like if we look at line segment, let's go with FD here. So line segment FD, or sorry, I should say line FD, because since we're talking about skew lines, we'd want to talk about these continuing on forever and ever and ever. So now, I know it can't be on this bottom base here, because then they're on the same base, they're on the same face. It couldn't be FE or ED, because 1, it's on the same face, and 2, they would intersect. So we need a line that is off of this front face here, but that would also never intersect. So if I look on the back face, we could say line BC. All right, skew lines are a little tricky, guys. We're not going to do a whole lot with them, but just understand they don't intersect, and they're on different faces. Okay, so again, skew lines, they don't intersect and they're on different faces. All right, so now we want to talk about cross sections. So interesting shapes can occur when a plane intersects or slices a three-dimensional figure. The intersection of the figure and the plane is called a cross section of the figure. So we can draw and describe the shape resulting from the following vertical, angled, and horizontal cross sections of a cone. So a vertical slice, we know vertical goes up and down, so that means we're going to take a plane. So think of taking a piece of paper and slicing this cone vertically, so going down to create a triangle. So if I take this and look at it in front of me, kind of hold it at eye level, you want to think about what shape do you see, what two-dimensional shape do you see. That's your vertical slice. So in this case, it would be a triangle. I'm going to hop over here to our horizontal slice. It's very similar to the vertical slice, except this time we're going horizontally. So again, think about taking that piece of paper and slicing across, so like the horizon, to create a circle cross section. So for your horizontal slice, you want to think about what the base looks like. Now your angled slice, it can be a little tricky because it depends on what angle we are creating the slice at. So if I took a angled slice, as you see in this picture here, the cross section would be a parabola, which if you don't know what a parabola is, it's going to look like this. So that's what that cross section would look like. So again, if we draw these real quick, this one will be a triangle. Again, think about holding it at eye level and what two-dimensional shape do you see. For your horizontal slice, think about what the base is. So since it's a cone, it'd be a circle. Your horizontal is honestly the easiest one to think about, guys, because again, it's just whatever your base shape is. Alright guys, this lesson had a lot of different information in it, so I want you to go ahead and try some of the things. So go ahead and pause the video here, take a look at this polygon here, and try to name all these different pieces. Alright, so go ahead and pause if you haven't already. Alright, hopefully you guys actually paused, and now we can go over these answers. So I see I have two bases. All of my bases, all of my faces are rectangles, and no matter which direction I go in, there are two of them. So we would call this a rectangular prism. Again, prism meaning two bases. Now, to name a vertex, where you're going to pick any one of the points. So if I start, I have E, I, J, F. Then on the bottom, we have L, K, it's a K there, H, and G. Okay, so then our edges, anywhere that we see that these connect, make sure you have the line above representing a line segment. So if I just start back at E again, we have segment EI, I have segment IJ, segment JF, and segment FE. So that connects all of our top vertices. Then jump to the bottom, we have segment HL, we have segment LF. Oops, sorry, that's not an F. LK, rather. And segment KG. And GH. Okay, now we also have to connect top to bottom. So I'm running out of room here. Hopefully I've hit the ones that you guys have listed. Just know that we also have segment JK, FG, IL, and EH. Again, you only needed to list one of them, so you don't need all of them. Okay, so for our face, we have, if I erase these lines here so we can actually see our vertices again. Okay, so for our faces, if I start at my top face, we have E, I, J, F going around. Our bottom face, we have H, L, K, G. We have our, those are our bases. We also have our sides. So J, K, G, F. We also have I, E, H, L, and then we also have I, J, K, L, and E, F, G, H. Again, I'm just running out of room. Alright, last but not least, pair of skew lines. There are a ton of them that you could have done here. I'm just going to give you one or two. So I see line EI would never intersect and is on a different face than line HG. So again, EI and HG, they are on different faces and would never intersect, making them skew lines. So that's just one example there. Alright, last but not least, having you guys try out a few of these cross sections. So go ahead and hit pause and describe what these cross sections would be. Alright, I hope you guys actually hit pause. So here on number 13, this first one here, we see it is a vertical slice. So if I held this up to think about what 3D object is there, or sorry, 2D object is there, we would have a circle. So we draw a circle, right circle. Right, our can here, here's an angled slice. If you see the dotted line here, it looks like it should be a circle, but it's actually not. It's more of an oval. And our last one, our horizontal slice. Think about what your base looks like. In this case, our base is a square. So that would be our horizontal slice. All right, guys, for your cross sections, make sure you're remembering what vertical, angled, and horizontal would mean. Sometimes you'll be given a picture, sometimes you might just be given the words, so you need to be able to describe them both ways. All right, guys, that is the end of section 12.4. There's some homework posted, bell ringer, hopefully you already did the bell ringer, and an exit ticket.